Then you'll do one on your own, and then I'll show you a third kind, which is very similar, or a second type of problem, which is very similar to the first. We're going to use the same formula from yesterday, except this time we're going to have all the information on the right. We're going to have the first term, the rate of growth, and what number of terms we have. And today we want to add up all of these terms. Now we want to do it without actually adding them all up individually. Now in the geometric formula, we have to know the first term and the last term of the sequence. What's nice about the geometric is you don't have to know what the last term of the sequence is. This formula, by knowing the number of terms, if it's 8 terms, 10 terms, whatever, you can simply just plug that n value in there. It's not the easiest formula to work with, but once again, you don't have to know the last term. So here we go. As I go to fill in my values here, what is my first term? What is my T1? Okay, we get that right here, 8. Boom. All right. What is my R value? How much am I going up by? What is happening here? All right, going from 8 to 24 and then 24 to 72. Give me a heads up. Someone give me a shout out. What is our rate of growth? We want to help out here. How much is it going up by?
3 times 3.
3. 8 times 3 is 24. 24 times 3 is 72. Our R value is 3. This problem I'm going to give you, I want you to find the sum of the first 7 terms. Once again, I don't want you to find the 4th, 5th, 6th, 7th term and add them up. I want you to use this formula. It'll go much faster. We're going to find S of 7 terms. Okay. We will plug them in. 8, first term. 1 minus 3 to the 7th power. Down here, I'm going to have 1 minus 3. Okay. So we simply fill in the blanks. 3's go here, here, and here. The mistake comes in on this. Everybody does this. They get 1 minus 3 is negative 2. That's good. Okay. We're going to get negative 2 down here. We're going to have 8 right here. But they make a mistake. They go 1 minus 3 is negative 2, and they go negative 2 to the 7th. To show your work, you need to show this. You're going to go 1 minus whatever 3 to the 7th power is. So you're going to use your calculator. 3 to the 7th is 2,187. Okay. At this point, I can now simplify. Use our PEMDAS. Once again, inside of here, take 1 minus 2,187. I will get 8 times negative 2,186. Okay. At this point, you can finish this with your calculator, multiply this by 8, and then divide your final answer by negative 2. Give me your final answer here in a minute. You guys finish that off while I start the attendance process. Come on. All right, so 2,186 times 8. I will get negative 17,488 divided by negative 2. I will get a sum of 8,744. So once again, I don't need to know what the fourth, fifth, and sixth, seventh terms are. I can find the sum of the first 7 terms by doing that. Any questions on this one? All right, most of you are going to find this assignment to be easier than yesterday's. All right. I'm going to have you do the next one. And this one, the numbers are going to get smaller, so it might look a little bit different. I'm going to show you how to find the R. Let's do this. Let's go, let's find the sum of the first 10 terms of this sequence. Let's go 3 plus 3 fourths plus 3 twelfths plus dot, 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 dot. Now, the first term is easy to find. We have no issue with that. T1 equals 3. Now, all the problems I've given you before this, finding the R value has been pretty easy, but we got fractions here, and that throws some people off. If you remember from the first day of geometric sequence, I gave you a problem. It was 20, 100, 500, and so on. I said to find the R value, you can take any number and divide it by the one before it. 500 divided by 100 was equal to 5. Or you could take 100 divided by 20, and it also equaled 5. To find our R value, most of you can do in your head, but this one we're going to have to show a little bit of work. So to find our R value, I'm going to pick one term, pick one of these, 3 fourths, and divide it by the term before it. So 3 fourths divided by 3. Now 3 is not a fraction, but to do this problem, I'm going to divide by 1, 3 divided by 1 to make it a fraction. And if you remember that dividing, goes back to trimester 1, dividing a fraction by a fraction is the same thing as multiplying the first fraction by the reciprocal, by the flip of the second fraction. If I do that, I get 3 over 12, which reduces to 1/4. So your R value for this problem is going to be 1/4. All right? Because the value is less than 1, the numbers get smaller. So right now I'm going to give you about 3 minutes to find the sum of the first 10 terms. You guys plug all the values in. If you want to turn 1/4 into a decimal, go ahead and do that, 0.25. All right, give you about a minute to try and finish this one up. All right. I'm gonna start out. I have 3 as my first term. In my head, I can do 1 minus 1/4. I know that's 3/4. Or 1 minus 0.25 is 0.75. All right. Then I'm gonna need my calculator. And I'm gonna show you a couple tricks on here. I'm gonna have 1 minus 1/4 to the 10th power. So I'm gonna go 1 divided by 4. I'm gonna get an answer of 0.25. And then I'm gonna hit my exponent button. I'm gonna type in 10, okay? I'm gonna get a really, really long decimal. It's 0.000, a total of 6 zeros. 5, 6, 9, 5, 3, 6. All right, now, what you can do on a regular calculator is down, for example, on this bottom, I have this button called ANS. That stands for the previous answer. So what I can do now is I can go, okay, 1 minus, then I hit my second button, I hit that ANS, and it'll subtract that last answer I have in my calculator. Where's my marker? And I get a really long decimal, 3 times 0.9999, rounded on my paper, and I have 0.75. So I'm gonna take that number times 3. I'll get 2.999 divided by 0.75. My answer is 3.99. Right. You could also, if you wanted to, you could round that to 4. All right. You're only going to get these when these numbers go down and they're kind of yucky. Any questions on any of those? All right. Okay, the last problems, the last examples you're going to get at the bottom, okay, are written in what's called summation notation. Okay, this is the Greek letter for sigma. It stands for sum. It stands for adding up everything that you have in your sequence. And it's going to put a number down here, k equals 1. And they're going to put a number up here, say 5. All right. And what this saying is you're going to have a total of 5 numbers in your sequence. Pick a number here. We'll go 9. And I'll go 3 to the k minus 1 power. Okay. Now, what this is asking you to do is to plug in prop numbers 1, 2, 3, 4, and 5, because it's going 1 to 5, and come up with 5 numbers in your sequence, and then add them all up. Okay. Do not write this down. I'm going to show you what it's mathematically asking you to do, but we're going to use our formula. I'm going to give you all the tricks to this right off the top. What it's asking you to do is plug in 1 for k, 2 for k, 3 for k, 4 for k, and 5 for k. So term 1 would be equal to 9 times 3 to the 1 minus 1 power. Term 2 would be 9 times 3 to the 2 minus 1 power. Term 3, once again, don't write these down. You don't have to do this. 9 times 3 to the 3 minus 1 power. Term 4 is 9 times 3 to the 4 minus 1 power. And the 5th term, because they're going up to 5, would be 9 times 3 to the 5 minus 1 power. And what you'd have to do is you have to work out all 5 of these and then add all 5 of them up. But there's a shortcut here. Okay, the shortcut is this number right here is your T1. This number right here is your R. This number here, as long as this is 1, this number right here is your N. So you have everything you need to do this formula. You have your T1 of 9, R value multiplied by 3, and we want to find the sum of the first 5 terms. So don't do this. Use your formula to find S of 5 right now. I'll give you guys 3 minutes to finish this one up. All right, let's see how we did on this one. Okay, once again, everything you have is in here. You don't have to do that stuff over there. So we'll plug it in. 9 is our first term. 1 minus 3 to the 5th power, all over 1 minus 3. We'll get -2 in the bottom again, right? 1 minus, now 3 to the 5th power. If I use my calculator, 3 to the 5th, we'll get 243. I get 9 times negative 242 over negative 2. 9 times 242. I got 2,178 negative divided by negative 2. The sum of the first 5 terms of this sequence will be 1,089. Does anybody have any questions on this one? Any questions?
All good here.
All right. So, like I said, today